So I'm going to remind you of solving this exponential by changing it to a common base. This is 2 raised to the x plus 6 is equal to 32. That 32 can be rewritten as 2 to the 5th. So we rewrite it as 2 to the 5th. Now we have common bases. We have a base 2 on this side, a base 2 on this side, so we just drop the 2's and set the exponents equal to each other. And now this is an Algebra 1 problem where we just solve for x by doing the opposite operations, and we end up with x equaling -1. But that doesn't work for all problems because we cannot change this 10 that we have over here, this 10 right here, we can't change that 10 into a base 2 because 2 raised to a power, it's not going to be a whole number. So since we can't change that 10 to a base 2, all we can do to this problem is rewrite it as a log. So you rewrite it as a log, the base stays the base, and the other two numbers switch places. And now this has to be evaluated using a calculator, and depending on which calculator you choose to use will determine how you do it. If you're using this Desmos graphing calculator, then it's just a matter of finding the log function that has the base, that gives you the ability to type in the base, and that ends up being having a value of 3 point, oh my goodness, it went away, 3.32. Want to round to 2 decimal places. So this log base 2 of 10 is about 3.32. Now that's not the only way to do that. If you choose to use a different kind of calculator, then you may have to use what's called change of base. For example, if you want to use the Desmos scientific calculator, if you go looking for a log function, the only option they give you is this log function right here. And notice it completely skips giving you the option to put in a base. That's because it's an automatically understood that the only thing you can type in is a base 10. So what you have to do on this is you have to type in this problem using the change of base formula. And I'm pretty sure Professor Trevino showed you how to do that on another video, but you just separate this. Over here you separate this log base 2 of 10 and you turn it into log base 10 of 10 divided by log base 10 of 2. And notice it did give us the exact same value right here, 3.32. So it doesn't matter how you do it. Let's see, I made a copy of, I did a screenshot of my phone calculator, and notice the only log option that you have on this one is a base 10. So if you were using your calculator, that's like on your phone or some other calculator, you would have to do the change of base formula and type this into your calculator. But it's going to give you the same thing, 3.32. Okay, so if you're solving exponentials and the exponent and its base, if there's anything else on the side of the equal sign like this, like problem number 3, you have 3 times your base and your exponent, you've got to get rid of that 3 first. So the only thing that you can have when you write a problem as a log, the only thing you can have on that side of the equal sign is your base and your exponent. So over here we've got to get rid of that times 3, and the way we get rid of the times 3 is to divide both sides by 3. So this becomes 2 raised to the x is equal to 15 divided by 3 is 5, I believe. So now we rewrite this. This becomes log base 2 of 5 is equal to x. And you can type it in, whichever calculator you want. Even on the Desmos graphing calculator here, you can type it in. You don't have to use the base 2. You can, and I'll show you. If I do log base 5 this time divided by log of 2, log base 10 of 5 divided by log base 10 of 2. That's how you can enter log base 2 of 5 by using the change of base formula, and that comes out to be 2.32. So x is about 2.32. And of course, the only advantage to doing that is that you don't have to go to the functions and, I put it on the same line. I didn't mean to do that. I meant to do this. Functions, and then log base 2 of 5 ends up being 2.32. Okay, so let's see, the next problem is another 3 right here. We have a 3, we have to get rid of that, so you divide both sides by 3, and that leaves you 7, I believe. I have my base, and my exponent is the only thing on this side of the equal sign, so I'm ready. The base 2 and the exponent is x minus 6. I'm ready to rewrite that as a log. So I've got log base 2 of 7 is equal to x minus 6. Okay, well, my x is not all by itself this time, so I do have to add 6. Be careful right here. This is where people are going to mess up, because log base 2 of 7, okay, I do not add the 6 to the 7 and make that become log base 2 of 13. You do not do that. You calculate this value first, log base 2 of 7, and then you add 6 to that number. So it does matter what order you do that in. So if I go to my calculator now, let me move it over here. I'm going to type in log base 2, and I'm going to put in parentheses the 7, and see that gives me the answer of log base 2 of 7, and then I'm going to say plus 6, and then it adds 6 onto the end of that. So I end up with 8.81 if I'm rounding to one decimal place.